Moving on to question 3, we're asked that the variables x and y satisfy the relation 2 to the power y equals 3 to the power 1 minus 2x. Okay, by taking logarithms, show that the graph of y against x is a straight line. State the exact value of the gradient of this line. Okay, so this is the equation we have been given for the line. And we need to show that this is a straight line and we need to find out the value of the gradient. Now, what is the equation of a straight line? We know this, it is y is equal to mx plus c. So we need to show this in the form y is equal to mx plus c. So we need to take log on both sides. You can either take ln or you can take log, but we can see in the next part that we have been asked in ln. So I would prefer taking that, otherwise there is no preference. So I will apply ln to both sides and it will look like this. Now we know that this is a log rule. If I have ln 2 to the power y, that will be y ln 2, because whatever you have in the power will shift to the coefficient. So that way I can write y ln 2 is equal to the same way 1 minus 2x ln 3. Now I am going to open my bracket, and so 1 times ln 3 would be ln 3 and minus 2x ln 3. Okay. Now I want to divide everything by ln 2 because I want only y as the subject to make it in this form. So I will do y ln 2 over ln 2 is equal to ln 3 over ln 2 minus 2x ln 3 over ln 2. And a little bit of rearranging to get it in the form I want. This will cancel and I will just have y is equal to ln 3 over ln 2 minus 2x ln 3 over ln 2. And let me just rearrange this. So y is equal to minus 2x ln 3 over ln 2 plus ln 3 over ln 2. So now this looks like y is equal to mx plus c, and my m is going to be this. So if I isolate that, minus 2x ln 3 over ln 2 can be written like minus 2 ln 3 over ln 2 times x. So this part essentially is my gradient. So the answer to part A would be minus 2 ln 3 over ln 2 as my gradient, and this is my line equation, and I have shown that it is a straight line. For part B, they want us to find the exact x-coordinate of the point of intersection of this line with the line y is equal to 3x. And they want the answer in the form ln a over ln b, where a and b are integers. So now we have two line equations. One is this one and second is this one that we just found. So whenever they want us to find the intersection of something, we will just equate it to each other, okay? So we have y as a subject here and over here, so we can easily equate these two lines to each other. So we are going to do 3x is equal to minus 2 ln 3 over ln 2 of x plus ln 3 over ln 2. Now we have ln 2 over here and here, so to get rid of it, I will multiply the entire thing equation by ln 2. And so I will end up with 3 ln 2 times x, and from this side, the right hand side of the equation, the denominator will get cancelled, so I will have minus 2 ln 3 times x plus ln 3. And I will just send this to the other side, so I will have 3 ln 2 times x plus 2 ln 3 times x equals to ln 3. So I have everything containing x on the left hand side of the equation, and I will take x common and get 3 ln 2 plus 2 ln 3 is equal to ln 3. Now, a log rule I know is that if I have 3 ln 2, I can send the coefficient into the power and it will become ln 2 cubed, and 2 cubed is 8. So I will end up with ln 8. Now, let me just write that over here. 3 ln 2 will become ln 8. And if I send 2 into the power here, 3 square will become ln 9. And that is equal to ln 3. Now, I have ln 8 plus ln 9. And another law of logarithm I should know is that if I have ln A plus ln B, I can multiply A times B. And on the other hand, if I have ln A minus ln B, I can do ln A over B. So these are laws of logarithm you should also know while doing A-level math. And if we apply that over here, we will get x times ln 8 times 9 is 72 is equal to ln 3. And if I send this to the other side to get only x as a subject, I will be having ln 3 over ln 72. And as you can see, 3 and 72 are integers, so our answer is in this form and our question is complete.